On January 2, 1959, the USSR launched the first spacecraft beyond the Earth orbit into a trajectory around the Sun. The E1 number for probe was designed to hit the Moon but missed it due to navigational errors. Preparations for the launch of the E1 number for Lunar probe were hindered by the New Year celebrations on December 31, 1958, formally still a workday, on the morning of January 1, 1959. As the launch vehicle with the spacecraft was rolled out from the assembly building at Site 2 to the launch pad, an officer responsible for tracking the mission remembered running from one mobile ground station trailer to another to fill in for his out-of-commission colleagues. Nevertheless, all final tests and telemetry processing were completed successfully, and the launch vehicle was cleared for fueling and liftoff next evening, on January 2, 1959, after 3 failed attempts. The USSR finally succeeded in launching a spacecraft beyond the Earth orbit. The 3-stage launch vehicle 8K-7 B-126, which was based on the R-7 ballistic missile, lifted off from a launch pad No. 1 in Turatem at 1941 to 24.1 Moscow time. It carried the E1 No. 4 spacecraft intended to impact the Moon on a direct escape trajectory without first entering the Earth orbit. The 361.3 kilogram space probe was equipped with a transmitter, a telemetry system, a power battery, and a set of scientific instruments designed to study cosmic rays, gas and particle content in the interplanetary space, solar radiation, and the Earth's magnetic field. Moreover, the 3rd stage of the rocket, designated Block E, which was intended to send the spacecraft toward the Moon, had its own payloads, including hardware designed to release a sodium cloud in space in order to create an artificial comet. The main purpose of the experiment, described as a navigational aid helping ground control tracking mission, slightly more than 12 minutes after the liftoff, the launch vehicle enabled its 3rd stage for the first time to accelerate beyond 11 kilometers per second, which was enough to leave the gravitational field of the Moon immediately after the engine shut down. The transmitter RTS-1 to be on board the E1 probe was activated, and officers at the IP-1 ground station in Turatem saw a signal on their monitors, triggering an instant celebration. However, while they were congratulating each other, the eastbound spacecraft went out of range of the IP-1 station right thereafter. Yevgeny Gabenko called the station and asked whether officers or his engineers at the site had seen telemetry signals from the velocity vector indicator. Only then controllers realized that neither live indicator nor a tape recorder had registered this crucial information. For predicting the exact path of the probe, they speculated that the telemetry component of the RTS-1 transmitter had failed. It could still be used as a radio beacon for tracking the mission's trajectory, but turned out to be useless for getting any other data from the spacecraft. Default text, according to a memo sent to the Kremlin. The Obyekty vehicle reached its solar orbit 732 seconds after the liftoff, as it was flying 1,290 kilometers above the USSR, east of the town of Tura, at 20:03 Moscow time, around 22 minutes after the liftoff. The rocket's eastbound ground track went beyond the Soviet territory, taking it over the Aleutian Islands and Hawaii. The Soviet ground stations in Turatem, Yeniseysk, Petropavlovsk, Kamchatka, and Makat were still able to listen to the E1 for the first 40 minutes of the mission. It then went beyond the range of the Far Eastern stations. All data gathered during the initial phase of the mission was automatically transmitted to the Calculation Center of Vienna I4 Research Institute in Bolshevo, and to the fastest Strela computers of the Calculation Center No. 1 of the Ministry of Defense, Applied Mathematics Department of the Academy of Sciences, and Moscow State University. In the meantime, as the spacecraft was climbing away from Earth instead of circling it, its eastward motion relative to the Earth's surface was slowing down, until the planet's own rotation started overtaking it. As a result, around 2 hours after the launch, the probe appeared making a giant arc over the Pacific Ocean and drifting back westward and south over northern part of New Guinea, southern Sumatra, the Indian Ocean, and Africa. By that time, the spacecraft was flying away from Earth. However, due to Earth's rotation, the vehicle's ground track drifted from east to west, giving ground controllers 12-hour windows to listen the probe's transmissions interrupted by 12-hour breaks As the Earth turned around its axis, the data analysis from binnacle and binnacle D trajectory measurement stations, which could track the probe up to a distance between 10,000 and 20,000 kilometers from Earth, did not confirm the rendezvous with the Moon. The measurements from the velocity vector indicator from a backup Jupiter transmitter also did not match the required parameters. 200 to the actual velocity was determined to be 11.3 for kilometers per second relative to the surface of the Earth, as it transpired later. A 2-degree error in pointing of a ground-based radio control antenna used during the powered flight of the rocket gave the one spacecraft extra 42 meters per second in velocity. Essentially, the spacecraft would now cross the lunar path before the Moon had a chance to come close enough to pull the probe into its gravitational field. The spacecraft was reported to be in a 146 by 197 million kilometer orbit around the Sun between orbits of Earth and Mars, thus becoming the first artificial planet of the solar system. The problem with ground radio control system affected the operation of the second stage, which was mainly responsible for fine-tuning the mission's trajectory. The autonomous flight control system on the second stage, inherited from the R-7 missile, would normally cut off its engines based on data from acceleration sensors. However, this mode was not accurate enough to ensure a rendezvous of the payload with the Moon. To resolve the problem, the engine cutoff function during the mission was transferred to a more accurate radio control system mounted on top of the second stage. However, due to wrong setup on the ground, the second stage was cut off only after it had run out of one of the propellant components, and the engine's turbine, free of its normal loads, went into overdrive and issued the turbine emergency contact command, or AKT. This delay apparently had a domino effect on a 6-minute burn of the blocky third stage, whose autonomous flight control system cut off the engine according to its pre-programmed sequence. The evaluation of telemetry later showed that engine was cut off after 731.2 seconds in flight. The flight control system then commanded the probe to separate from blocking. However, the operation did not take place. Fortunately, for antennas of the RTS-1B transmitter on board the E-1 probe deployed just 140 seconds into the flight, moments after the release of the payload fairing. As a result, the probe stranded on its third stage still was able to transmit signals to the ground. However, a pair of antennas of the Jupiter-1 transmitter, located on the opposite side of the ball-shaped probe and hidden inside the structure attaching the spacecraft to the third stage, obviously could not open normally. Still, communications officers were getting signals from Jupiter just fine. Veterans of the project speculated that Jupiter could route signals via antennas of the third stage, along with its own shortwave radio, or spring-loaded antennas on the E-1 managed to stick out through small openings in the holding structure. Another possibility was that after the release, the antennas could press against the third stage, turning its metal body into a natural antenna. On January 3rd, at 3:57 Moscow time, as the stack was free-flying over the Indian Ocean, 113,000 kilometers from Earth, a sodium cloud was released and captured on film by a station near Karaganda. Even though bad weather did prevent observations at most other sites, the artificial comet turned out to be a poor aid in tracking the mission. During a day, a deputy head of the NII Research Institute responsible for mission control, Georgy Tulin, sent a memo to the Kremlin reporting that by 11 o'clock Moscow time, the spacecraft had reached a distance of 200,000 kilometers from the Earth as it was drifting across the Atlantic and was about to go out of range of a deep space ground station in Samais. The spacecraft was expected to re-enter communications around midnight. Tulin's memo said that based on the results of the calculations, it is possible confidently expect reaching the vicinity of the Moon around 7 hours in the morning on January 4th. However, another memo sent by Tulin's boss, a Sokolov, couple of hours later said that results of the telemetry processing confirm that the rocket will pass near the Moon and turns into the first artificial planet, or become the artificial satellite of the Sun.
The minimal distance of the rocket from the surface of the Moon during a flyby based on measurement will be 6,000 to 8,000 kilometers, or to its diameters.
The artificial planet's orbital period is still being calculated, Sokolov wrote. Interestingly, Sokolov, Julian and a number of other officials signed yet the most detailed memo. Apparently few hours after two original documents. In it, they claimed that the orbital elements of the rocket and its predicted pass in the vicinity of the Moon had been determined to 0.5 hours after the liftoff, or at 22:15 Moscow time on January 2nd. Nevertheless, the official telegraph agency of the Soviet Union, TASS, finally announced at 13 o'clock Moscow time on January 3rd that the space rocket would reach the vicinity Y of the Moon at 7 hours on January 4, 1959. The TASS statement also said that the last stage of the space rocket, with a mass of 1472 kilograms without propellant, had been fitted with a special container carrying measuring equipment for scientific research inside it. Such a phrasing was a clear hint that the spacecraft had not separated from the stage on January 4th at 5:52 Moscow time, or 34 hours after the liftoff. The 1No-4 flew by the Moon, passing from 5,000 to 7,500 kilometers from its surface or its center. According to various sources, on January 5th, around 10 o'clock Moscow time, the probe stopped transmitting after a 62-hour mission, as it reached a distance of 597,000 kilometers from Earth. Even though its batteries were certified to work for only 40 hours, the spacecraft was expected to reach the perihelion closest point to the Sun of its orbit on January 14, 1959, passing within 146.4 million kilometers from it. By the beginning of September of the same year, the probe would reach the aphelion, located 197.2 million kilometers from the Sun. Years after the launch of E-1 number 4, the official Soviet sources started identifying the mission as Luna-1. After the first Luna, the USSR has carried out 23 consecutive moon exploration missions. For 17 years, we will continue to learn about these missions in the following videos.